This is Physics 1 course. In this video I'm going to teach Newton's third law. The law states that if body A exerts a force on body B, then B also exerts a force on A. The two forces are equal in magnitude but opposite in direction. In order to see what this exactly means, I'm going to solve a couple of examples. Let's say I'm standing on the ground. So here is the center of the earth, and the earth is pulling me toward the center using gravitational force. So therefore this is mg and the direction is downward. So this means I am pulling the earth upward with the same magnitude mg but in opposite direction. Now let's say I am also moving forward with velocity v. So in that case I am actually exerting a force on the ground toward back because I'm moving forward. So let's say this is F mu. Then the ground, according to the third law, exerts a force on me forward, and this is this force that moves me in this direction, that causes V. Otherwise, if there was no friction, like on a frozen ground, then there is no friction, then it will be slippery and I fall down. I cannot move like that. Now let's say there is a bird moving toward a wall and it hits the wall at some point. So in that time, since the bird is stopped from velocity, let's say v naught, it stops, so velocity becomes 0. That means a force is being exerted on the bird in this direction. Let's say it's F1. Then that means the bird is also exerting a force on the wall, which is in the other direction. Now let's say there are two boxes, M1 and M2, and I'm pushing the first box with a force F. Therefore the box is also pushing me backward with the same force F. Now I am exerting a force to the ground. So let's say this is the ground. I'm pushing the ground backward with, let's say, F1. Then the ground is pushing me forward with F1. Now box M1 also pushes box M2 with a force, let's say F2, and box M2 pushes box M1 with the same force but in opposite direction, F2. Now let's assume all of these move with some acceleration a. Since they all are kind of attached, they are not separated, then acceleration for all of them is the same. So now I'm going to use Newton's second law. So acceleration is F divided by the mass, right? So it is equal to, this is the net force. Let's say for the person, so acceleration of the person is F1 minus F. So for the person, it's F1 minus F divided by, let's say, mass of the person. So now acceleration, we said acceleration is the same for the box and the person and the other box, and for this larger box acceleration is F minus F2 divided by M1, and the same thing for the second box, F2 divided by M2. By the way, I have assumed that the two boxes are somehow not feeling the friction, like for example by having a wheel or something else, or I have lubricated the surface of the bottom of the boxes, so somehow they are not feeling the friction. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.